Hello friends, welcome to everybody. We have seen in our previous video about the axial tilt of our planet and what are the effects of this axial tilt. Today we are going to study one curious case in which the axial tilt is to the extreme and the effects of this extreme axial tilt. We all know that our solar system has 8 planets. Among them, some of the planets are tilted in a very curious manner. Let us see. The first planet is Mercury. The Mercury's axial tilt is almost negligible. It is 0.01 degree. So we can say that it's almost 0. Then the second planet is Venus. Its axial tilt is 177 degree. Or we say that the planet Venus rotates in a reverse direction compared to other planets. For example, our planet Earth rotates from west to east. So the sun rises in the east and sun sets in the west on our Earth. But on the surface of Venus, sun rises in the west and sun sets in the east. This is because the Venus rotates from east to west. Now next comes our own planet Earth. Its axial tilt is 23.45 degrees. Then comes the Mars. Its axial tilt is almost equal to Earth, 25.4 degrees. Then comes Jupiter. Its axial tilt is almost negligible, around 3.12 degree. So we can say that Mercury and Jupiter are almost 0 in their axial tilt. Then comes the Saturn. This is also almost equal to our Earth, around 28 degrees. Sorry, it is I think around 25 degrees. Then comes the Uranus. This is one of the most curious planets in the solar system because this planet's axis of rotation is tilted by 98 degrees. Because of this, the Uranus moves around the sun more like a rolling ball than like a spinning top. See, this is the axis of rotation of Uranus. It is tilted by 98 degrees as you can see it. Because of this, see, this is the pole of Uranus, this is its north pole and this is its south pole. As we have seen, in case of our planet Earth, the tilting will be like this. So, our poles never get direct sunlight. But in case of Uranus, as it is tilted in this manner, 2 times in the year means a year of Uranus, these poles get the direct sunlight. Here, the direct sunlight is on the north pole. Here, the direct sunlight falls on the south pole. We all know that our planet Earth takes 365 days to complete one rotation or one revolution around the sun. That 365 days we call it as one year. To be exact, the time taken by our Earth to complete one revolution around the sun is 365 days, 5 hours, 47 minutes and 48 seconds. This is the exact duration of 1 year on our planet. But in case of Uranus, it is far from the sun. Its distance is 19 times the distance of our planet. So Uranus takes 84 years to complete one revolution around the sun. So 1 year of Uranus is equal to 84 years of our planet. So on the surface of Uranus, even though Uranus completes one revolution around its axis in just 17 hours and 14 minutes, its day will be as long as 42 years. Let us see how it is possible. Now we have seen Uranus is here. It is rotating around its axis like this. Okay, this is the axis of rotation and here it lies in front of the sun. The sun rays are directly falling on the north pole at this moment, and as the planet is rotating like this, its axis of rotation is almost perpendicular to the sun. So here the light falls, but here the rays of sun will be falling like this. So this portion of Uranus is under light and this portion is dark. This is night time on Uranus and this is the daytime. Now, as we have seen this, it is rotating like this. So, even though it completes one rotation here it will be daylight only. Even if it completes one rotation, there will not be any night, because on our planet Earth we have seen that during every one rotation we see 12 hours of day or 12 hours of night, at least 10 hours of day or 10 hours of night, like that. Some day and night cycle will be there, but on Uranus it will not be like that. As the planet takes 84 years to complete one rotation around the sun, as it completes one rotation around its axis, the daytime continues here, the night continues here, and it continues for 42 long years. Once this north pole is under light, there will be perpetual sunlight for 42 years, and at the time the south pole will be under darkness. Now, as the planet comes to the other side of the sun here, now this is the north pole and this is under darkness. The rays of sun will be falling like this. So the south pole of the sun is under sunlight, the south pole of the Uranus is under the sun. Now here it will be daytime in south pole and night